This example is a small sample size example with a less than option. The student group maintains the average student must travel for at least 30 minutes in order to reach college each day. The college admissions office obtained a random sample of 25 one-way travel times from students. The sample had a mean of 24.4 minutes and a standard deviation of 9.6 minutes. Does the admissions office have sufficient evidence to conclude the commute is less than 30 minutes at the 0.05 level of significance? All right, again, step one, we want to set up the hypotheses. The null hypothesis, mu equals 30. In this case, we're looking at this from the admissions office standpoint. They're hoping to show that the mean is less than 30. So our alternative is mu is less than 30. All right, so step one, we've laid out our hypotheses. For steps 2 and 3, critical values and test statistic, we need to make a determination of which test. In this case, we know the standard deviation only of the sample, not of the population. And we only have a sample of 25. So that's a small sample, so we must use the t version of the formula. So to do that, we have the t-test. It is one-tailed because it's equal versus less than. Alpha is equal to 0.05, and degrees of freedom is equal to the sample size minus 1. So 25 minus 1 gives us 24 degrees of freedom. We go to our t-table. Find the alpha equals 0.05 one-tailed column, go down to the 24 degrees of freedom row, you'll see 1.711. Then we need to figure out the sign because this is one-tailed. When you have less than, we're concentrating on the left side of the distribution. We want a negative critical value. All right, so for the test value then, we've seen the t formula before. We plug the 24.4 sample mean in, 30 for the population mean we're looking for, 9.6 for the standard deviation, 25 for the sample size. Do the subtraction in the numerator and the square root in the denominator. I did the division in the denominator and then did the overall division, which gives me a test statistic of negative 2.917. Our critical value is negative 1.711. Negative 2.917 is to the left of that, down in the tail. It's in the tail. We reject the null hypothesis. Our conclusion is the actual average likely is less than 30. If we wanted to find the p-value, this is a little bit interesting. What we need to do is we need to use the t.dist.rt, which is the right tail formula. Then we need to look at the positive version, positive number, 2.917 of our test statistic, with our degrees of freedom, 24. And that will give us the p-value. Keeping in mind, the reason this works, the area to the right of positive 2.917 is the same as the area to the left of negative 2.917.